Good morning, my dear kids. In today's class, in the chapter optics, we are going to discuss the topic the prisms. So already we had in the previous class we discussed some numericals on the prism. So today we'll explore few more problems on the numericals on the prism that one. See, once again, I insist you on more the numerical analysis. Unless you don't uh, analyze more numerical. I'm asking you to analyze, not like something remembering. Each and every problem you have to think and you have to ask yourself the query like why only the method like this? Why this equation is this one? What is the reason why I should write this equation? Hmm? What is the purpose of writing this equation? So this analysis has to be done. Each and every equation, okay, what is the purpose of this? Why we are writing this one? So this analysis has to be done. It's not like something mere seeing the problem. So if you can analyze, so the clarity of concepts will build up. From there, what will happen? You can solve more number of numericals. I'm insisting on solving more numericals to tell you that when you go through so many numericals, then you'll get a confidence like okay, prisms I can manage. Hmm? So today I brought a few more very best numericals which will reflect the most of the best ideas of the prism. Hope at least after listening to my lecture, you feel you gain more confidence and you should be able to solve the problem. There is more. I do like students when they solve problems than me solving. So the whole my effort is to make you that this problem solving is something like it comes by interest and observation. You don't need any background, like you should be the class topper, you should have a good memory, genetic, like your parents, family background should be of good intellectuals. All these are not at all needed. To solve the problems, what happen? You must have the interest and the observation. You should be interested to know the facts. Like, okay, there's a question is there. What is the method is involved? Okay, what is the idea involved? Hmm? So, what equations I should bring here? Okay, how I should proceed? This interest is enough. With this, you can manage. See, it's not that you cannot you can solve all the problems. Not like that. 90% of problems you are able to solve. Okay, fine, good. Science is all about like 20%, not like 90%. If you are even 50% also, if you are able to manage, it's good that one. A better future, a better engineer is going to uh, come into the picture. Hmm? Okay, we'll begin. Let me talk less. Let me talk more physics. I'll start the class. Yeah. Okay, well, an equilateral prism deviates a ray through 40 degrees for two angles of incidence. The two incidence angle differ by 20 degrees. Find their value. Equilateral prism means like we know angle of prism is something. So hope you can recollect there's a curve what we had. These are the maximum, minimum deviations. Of course, problem is not related to maximum minimum deviation. There are two angles are there. It's telling that there are two angles are there for which the deviation will be maximum. The deviation will be so this is one angle. This let me call emergent angle. The two incidence angle differ by 20 degrees. So we know deviation. So we are not understanding. Okay, you do one thing. Take prism. Where are these angles? Okay, this angle will be like this. Okay, then this is delta I. This is the. This is the. I think this is what particular diagram, what background, what you should have. Okay, let's write what is the expression for deviation? I plus C minus A. So where is the deviation? This is what called as deviation. And the equilateral prisms deviate a ray through 40 degrees. So this is 40 degrees. I plus equilateral prism 60 degrees. So what is the value of I plus E equal to 100 degrees. Then you look at the question, the two incidence angle differ by 20 degrees. So therefore I minus E 20 degrees. Solving these two, adding the I equal to 60 degrees. If I equal to 60 degrees, E will be 40 degrees. Okay, this is our answer. Hope you are able to the background we need all this. If not that writing this equation, you need this curve background, this diagram like this. Okay, a ray is passing through the prism, then then what will happen? It will undergo refraction. This is deviation. This background should be there. Then these equations, what you know it. Then substitution. I want you to have this background first. Okay, we'll take the next one. Yeah, I'll take out my video. An equilateral glass prism can produce a minimum deviation of 30 degrees to the path of an incident ray. A transparent slab of refractoriness 1.5 is placed in contact with normal the refracting face of the slab, thickness of slab. Now calculate the minimum possible deviation. So there is a prism. There is a very beautiful problem is there. We have there's a prism. Okay, the ray will undergo minimum deviation. At minimum deviation, what is the condition? The, ref the refracted ray should be parallel to the base of the prism. This is the base. No? So this is the refracted ray should be parallel to the base of the prism. Okay, this is at minimum deviation. Now if I bring a slab, what conditions will come? If I introduce slab in the sense, okay, I'll like this, the slab is blocked. What slab does? Slab will not produce any deviation. Everyone knows this. Slab will not produce any deviation. So the ray, when it passes through the slab, it will not undergo deviation, that's all. So the minimum deviation will remain same. Nothing will happen. There won't be any further deviation. Of course, these two are there. So slightly here, bending of ray will occur, and but this will be parallel to this one. Maybe it is not here. I think I'll redraw it. So it should be like this. Slab will not produce any, it will only produce lateral shift, but there won't be anything called like a minimum deviation. Means there won't be anything, the angle made by it will remain same. So I just wanted to bring this theta, this is the mistake. So there won't be any change in that minimum deviation. What was the minimum deviation? The same it will remain same. Because the slab will not produce any deviation. Okay. So minimum deviation. remains same. A triangular medium has having refractive index mu equal to mu naught plus ax, where x is the distance along x-axis from origin, and mu naught equal to 4 by 3. A ray of is incident normally on a face OA at the midpoint of OA. Find the range of value of A so that the light does not escape to the face AB when it falls first time on the face AB. Yeah, something I think this angle is missing. I'll write it here. 53 degrees. So what will happen to this ray? Let me explain through little diagram. So the ray incident here, when it falls, light does not escape through the face AB. Does not escape means it should undergo TIR, is telling. Yeah, you see the sun. So this particular light now should undergo TIR. TIR means we'll just take a situation of like this, just TIR. So this angle is how much? 53 degrees. This is 53 degrees. This will be 37 degrees. So this is the incident ray. If the ray undergoes TIR here at this point, it will not escape from the path AB, no? So therefore, what is the basic condition? The 37 degrees must be greater than critical angle. So this 37 degrees. So what is the sine C is equal to 1 by mu? What is mu is equal to mu naught plus Ax. I'll give this distance here. This distance, let it be 1.5 meter. Some data is missing. So let this distance be 1.5 meter. Okay, this will become now the x. So sine C is equal to now 37 degrees should be greater than sine inverse of 1 by mu naught value is how much? 4 by 3 a, x is how much? 3 by 2. Solving this, sine 37 Okay, solving for this will get the value of A. I think problem is very simple. It need not to be. So the value of A will be should be greater than 2 by 9. The ray goes undeviated here because it is incident normally. It goes undeviated. Here it should undergo TR. So the angle of incidence here, this angle of incidence should be greater than critical angle. What is the condition for critical angle? Sin C should be equal to 1 by mu because the other medium is zero. Simple problem. Some mu varying inside the prism. Need not to bother. Still you can continue. Let's take the one. An isosceles glass prism has one of its face silvered. A light ray is incident normally on the other face which is identical in size to the silver face. The light ray is reflected twice on the same sized faces and emerges through the base of the prism perpendicularly. Find the minimum value of refractive index of the material of the prism. Something you must have the diagram. Okay, we'll proceed in this way. Okay, now we have to assume the diagram. So there is a prism we have. First we'll bring the prism. Okay, this is the prism. So this one of the face is silvered. This face is silvered, is telling. So the ray is incident normally. I think I have to first we have to construct the diagram here. Is incident normally on one of the face. Normally. Okay. Yeah, here we'll go it. Then it will be reflected. And it will undergo TIR and it will emerge normally. I think, see, this is the diagram which you should able to make a guess. Huh? This is something very important. This is the normal. No? Yeah, let's get into the discussion. Now this is the angle of prism A. This will be 90 degrees. I1 R1 0. So here we'll take theta 1 or refracting angle from theta 1 will write it. Theta 1 or theta 2. Theta 1 is 0 there. Do one thing. Theta 2, theta 2, theta 2, theta 2. This will be 90 degrees. So this is our prism A, B, C. This is the ray P, Q, this R. And the minimum value of refractive index of material of prism. Let this be theta. First we'll proceed here. A plus 2 theta equal to 180 degree. So therefore what is A is equal to 180 minus 2 theta. Then let's calculate the theta 2. Then we know here theta 1 plus theta 2. I'll do one thing, I'll make it R2. Now, if there's a prism, here I1 R1, what is I1 and R1? I1 and R1 are equal to 0. Everything I should redraw here. You're fine. Now I1 equal to R1 equals 0. Where is that I1, R1? Here. This part, you APQ, you treat like a prism, like this. There's a prism. Then angle of incidence is 0. Angle of refraction will be 0 at P. I1, R1. So R1 plus R2 equal to A, according to the prism concepts. As R1 is 0, so therefore R2 is equal to A. Now these are very important. From here we can get into problem very easily. So therefore, what do I can write? R2 is equal to A, 180 minus 2 theta. So next we'll go for angle PRQ. Angle PRQ. So this angle will be 90 degrees. So call this is say alpha. So alpha triangle PRQ. So we can write it as alpha plus 90 plus 2R2 equal to 180 degrees. Or alpha equal to 180 minus 90 minus 2R2, which is equal to 90 minus 2R2. What is R2? R2 is 180 minus 2 theta. So 90 minus 360 minus 4 theta plus 4 theta. Alpha is equal to 90 minus 2 R2. R2 value is substituted. Okay, fine. So this will become 4 theta minus 270. This is alpha. Alpha plus R3 should be 90. So what is R3 equal to? 90 minus alpha. What is alpha? 4 theta minus 270. So this will become 360 minus 4 theta. This is the value of R3. Now come for this angle. Let me call beta. Beta plus theta plus 90 equal to 180 degrees from the triangle RBM. So therefore beta plus theta equal to 90 degrees. So here beta equal to 90 degrees minus theta, and beta plus R3 equal to 90 degrees. Beta value 90 minus theta, R3 value 360 minus 4 theta equal to 90 degrees. Solving this, we'll get the theta. Therefore, theta 72 degrees. Now, here it's a mirror. This is silvered, this is there. Here it should undergo TIR. TIR. TIR occurs here. For TIR to take place, what should be the angle of incidence? R3. This should be greater than critical angle. This should be the greater than critical angle. So therefore, so what we'll write is like a R3 should be greater than C. So R3 is how much? R3 equal to theta. Somewhere I didn't write it. No, so therefore, so what we can write is like a, so sine of R3 should be greater than sine C. So what is value of R3? Sine 72 degrees. Sine C equal to 1 by mu. putting that. So sine 72 degrees equal to 0. So therefore mu should be greater than mu should be 1.053. Minimum value is asking, so we'll go for 1.053. Okay, this will be more meaningful for you. So this will be your answer, finally. Okay, some you see that lot of maths. I think students should look at the problem here. He has brought some maths into the picture. The relationship between the angles. You must know these angles. This triangle. Again we have there's a prism, angle of incidence and angle of refraction 0. R1 plus R2 should be equal to A. So therefore R2 is equal to A. This idea is very important. These ideas are very important. I think it's all about some triangles. You should be very extra alert in making observation of triangles. Nothing is there. You can manage. Let me take you to the next problem. A ray of light is incident upon one face of the prism in a direction perpendicular to the other refracting face. The critical angle for glass air interface 30 degree. Find the angle of prism assuming to be less than 90 if the ray fails to emerge from the other face. Okay, let's again we need diagram. We'll start with the diagram. This will be the ray is incident so will undergo refraction. So then some rough diagram. Then here it should be. I think there's a condition given. You read the question. 90 degree. This is A. This is the angle of incidence only R1, R2. This is the so first like this is 90 degrees. So call this angle alpha. So we know I should be equal to alpha. Then alpha plus 90 plus A should be equal to 180 degrees. Sorry, not I is equal to alpha. So what is alpha? Alpha should be equal to 90 minus A. I plus alpha equal to 90. Alpha equal to 90 minus A. So therefore I is equal to A. So there's a relation between the angles. Incident angle will be equal to angle of the prism. Okay, let's get into. So for the ray to undergo TIR, so what is R2? For the ray to undergo TIR, there's a second phase. There's a first phase. The ray must undergo TIR at second for TIR. Its second phase, what is the condition? R2 should be greater than critical angle. And we know R1 plus R2 is equal to A. This one. R1 plus R2 should be equal to A. So therefore, R2 I can write A minus R1 equal to R1 A minus C is greater than R1 or R1 less than A minus C. Taking sign on both sides, sign of R1 applying Snell's law, mu sin R1 sin I we know sin A because there is a condition, no? I is equal to A. So therefore sin R1 I can replace now here. So sin R1 equal to sin A by mu. So this will be expansion of this will be sin A cos C okay, now we know sin C value. Sin A I'll take common, so 1 by mu equal to cos C minus cot A sin C. If I take sin C also common, sin C is asking the find the angle of prism, no? We need A, no? Okay, this will be sin C. Okay, sin C by mu. Let me simplify. So 1 by mu is equal to less than. If I take the sin C outside, so this will become 1 by mu sin C mu sin C less than cos C minus cot A. So sin C is equal to 1 by mu. Okay, this will be 1 less than cot C minus cot A. So cot A equal to so this should be equal to less than cot C minus 1. So cot C value will be sin C 30 degrees as given. So it will become cot A less than okay, this is the angle of prism. Again, you have to be careful about the mathematics here. So this will be our answer. Okay, so we take the next one. No, this is a very simple problem. An equilateral prism has its faces made up of a transparent fiber sheet having refractive index 1.25, having thickness of 1 millimeter. The fiber prism is filled with a liquid of refractive index. Find the deviation of light ray incident on one face of such a prism at an angle of 45 degrees. It's asking us to calculate the deviation. So what's happened to this ray? Ray moving from rarer to denser, so it will bend. I'll show by red color. So what this particular thin prism, it will not produce deviation because when a ray of light passes through a slab, it will not undergo deviation. If you look at the reflected light, uh, something, I'll redraw it. This is what happens. So where is the question of deviation by the slab? Not there, no? So this will be parallel. Slab will not produce deviation. Slab will not produce deviation. So therefore, what is the use of this particular layer? This layer will not, the fiber layer will not produce any deviation. Okay, fine. So this is what a student asked, and that's why I just brought this problem. This yellow color layer, what I am will not produce any deviation. Slab. So similarly, this will act like a slab here. This part will act like a slab. So this fiber layer will not produce any deviation. What all deviation? The deviation will be only due to angle of incidence, this I1, equilateral prism, this R1, this R2, this I2. What is the deviation? I1 plus I2 minus incident angle. So deviation is find the deviation is asking. So this will be 45 degrees plus I2 minus say 60 degrees. So next sin I1 equal to mu sin R1. Sin R1 equal to the sin I1 will be 1 by 4. So this will be refractive index will be 1.25 sin R1. I'll get R1. R1 plus R2 is equal to A. Then again you apply mu sin R2 is equal to sin I2. This is A real. Okay, that one. So you calculate I2. So from here we'll get R1. Then you'll get R2. Substitute the value of R2 to get I2. That I2 will substitute to get the deviation. So that particular fiber will not produce any deviation. This is a very major thing. As it is thin. What all the deviation will be only due to liquid. The deviation will be only due to liquid. Okay. This is some lengthy problem. Let's try to read the question. Three right angle prisms are glued as shown in figure. An incident ray passes undeviated through the system except the refractiveness mu2 of middle prism in terms of mu1, mu3. Goes undeviated. The ray which is there, no, so it will undergo deviation due to first prism, second prism, third prism, but the emergent ray will be parallel to the incident ray. For that, what is the condition? How mu2 is related to mu1 and mu3? Okay, let's proceed here. So we'll go for the ray diagram. So here, this is the A. So the ray from slightly may not be parallel, may not be parallel. Not parallel. Okay. Then again. the ray will be, so this is the, okay, this one. So here, this is very important for me. Fine. So this angle is 90 degrees. This also 90. This also 90. So this angle also should be 90. Looking at the prism diagram. Hmm? Okay, fine. So how come this line will be parallel to this? This line will be parallel to this. I'm not doing any magic here. It's all about the geometry, nothing big. Okay, fine. So this will be normal, no? Okay, this will be normal for this face. As these two faces are perpendicular, so therefore this normal will be parallel to this face. And these two faces are having angle 90 degrees. Therefore, this normal to face 1 will be parallel to the face 2. So therefore, these two normals, the angle will be 90 degrees. This is the central theme of your problem solving, the geometry. Okay, let's all will go for it. So this angle is what I, R1, this R2, this R3. This should be the R4, R4, R5, R6, R7. This, not needed this line. Let's get into some. So from this R1 plus R2 should be 90 from prism concept. Similarly, R3 plus R4 should be 90. Similarly, R5 plus R6 should be 90. And this is the emergent tree. Huh? And this is the incident tree. I don't have a place. I'll write it here. And they're in fact parallel. Huh? You can see these two are parallel. So if emergent is parallel to incident tree, so therefore now what we can write something about the R7 and high and 90 degrees. So these two will become like a triangle. So R7 plus I should be 90 degrees as that parallel. So we'll have one more. So this is what I 90 degrees. This is R7. So therefore I plus 90 degree plus R7 equal to 180 degrees, or R7 equal to 90 minus I. Very important. You can't solve the problem without this data. Let's apply the Snell's law at all the faces. So sin I mu sine R1. So this will become R1 I can write as 90 minus R2. So this will become sine I is equal to mu cos R2. Or let it be R1 as it is. Huh? Let me not disturb. Let me not disturb this. And now afterwards mathematics. Huh? So next again mu1 sine R1 equal to mu2 cos R2. Mu2 sine R3. Yeah. Applying Snell's law, mu1 sine R2 should be equal to mu2 sine R. Mu2 sine R3. Any replacement can we do here? Mu1 sine R2. Okay, mu1 sine R2 I can write it as 90 minus R1. R3 I'll keep as it is. Mu2 sine R3. This is one equation. This is a one equation. Next equation is this one. Mu1 cos R1 equal to mu2 sine R3. Next again, applying the Snell's law, mu2 sine R4 this one. What is R4? I have to replace R5, that is, I have to replace R4. R4 I can write as 90 minus R3. So why you are doing like this? Just to bring the condition, because all these angles I should eliminate. I can eliminate these angles only when I square and add trigonometry. What is R5? R5 will be 90 minus R6. Mu2 cos R3 R4. Okay, so problem is there with my brain now, not thinking properly. This is R3. Sine of 90 minus R3 should be cos R3. Mu2 cos R3 should be equal to mu3 sine R5. This is one equation. Then last one, mu3 sine R6 equal to sine R7. So R6 I can write as sine of 90 minus R5. R7 I'll write it as sine of 90 minus R. So mu3 cos R5 should be equal to cos R. So this is the, now all these angles should get eliminated so that I'll get only the mu. So how to eliminate this all these angles here? So I'll call this equation 1, 2, 3. So we have to do some calculations such that the angle should get eliminated and only there should be the refractive indices must be there in the equation. I think adding up, squaring and adding 1 and 3, subtracting with this one. So here I'll do like this: 1 square, 3 square, minus 2 square plus 4 square. Okay, 1 square will be sin square I, squaring and adding we have to do. I'm not good in mu2 square cos square R3. This is a 1 minus of, the other side will be mu1 square sin square R1 cos square R4. I missed some terms I feel. Sin square I mu2 cos square 3 sin square I is equal to mu1. I'll rewrite somewhere I missed it. Nothing but these two I should equate, no? Equating to sin square I plus mu2 cos square R cube minus mu1 square cos square R1 minus. Okay, I'll write it a little bit lengthy. It says sin square I plus mu2 mu square cos square R3 minus mu1 square cos square R1 minus mu3 square cos square R5. This should be equal to mu1 RHS1 sin square R1 plus mu3 sin square R5 minus of mu2 square sin square R3 minus cos square R. We should solve all this. The angles, if you see this one, mu1 square, mu1 square. Regrouping, mu2 square mu2 square cos square 3 and mu2 square sin square 3. One more similarly, the color, therefore this will be sine square I plus cos square I. Mu2 square will be common. Cos square R3 plus sin square R3. Mu1 square common. Cos square R1 sin square R1. Mu3 square common. Cos square R5 all set equal to 0. So this will be 1, this will be 1, this will be 1, this will be 1. Okay, there's a relationship between the mu2 so 1 is equal to mu1 square mu3 square minus mu2 square. This will be your answer. A little bit lengthy. The calculations are, the theory is very small. So some very important things is like the diagram which I drew is something very important. Even I am also, you can see myself I struggled here because you have to bring some trigonometry ideas here. The idea of physics is about drawing this diagram. The rest of all these angles, Snell's law, okay, one equation 1, 2, 3, 4 is Snell's law, physics. Rest of everything is the trigonometry. Okay, of all this is very important things. This one, these things is what student has to make observation. Hmm? Okay, let's take the next one. Find the angle of prism A is asking. I think it's very simple. So we have here the deviation on y-axis, angle of incidence on x-axis. For a pair of angles, the deviation will be same. So therefore, this will become I1, I2. This will be deviation. What is the formula? What is the deviation? 28 degrees. I1, 18. Solve for angle of prism. 10, 32 degrees. Okay, the basic formula, the deviation suffered by that, this will be the prism. No? So when a ray of light passes through it, these are the angles I1, R1, R2, I2, this is it. And this will be the deviation. Okay, agreed. Whenever any curve comes, very easier, just have some basic conditions. We have one more problem. Let's discuss this also. Let me have water. Okay, now. For a glass prism, the plot of deviation versus angle of incidence I shown. Find the refractiveness of the glass and value of angle of I. The deviation on y-axis, the angle of incidence on x-axis. So we have this particular curve. There's a maximum deviation, there's a minimum deviation, and the angle for which minimum deviation is more given 60 degrees. So we'll do one thing. We know minimum deviation 60 degrees. Maximum deviation 63 degrees. And we have one more information is like maximum deviation is equal to, or say deviation in general formula. What is the deviation formula? Tangential deviation equal to I1 plus I2 minus A. If this is I1, this will be I2. And it is not maximum deviation. So sorry, this is not maximum deviation. So here this will be 63 degrees. I1. This I2 is what? 2I1. And minimum deviation is 60 degrees. So we know that minimum deviation mu is equal to sine of A plus delta minimum by 2 is equal to sine of A by 2. It is asking to calculate mu. We know minimum deviation 60. We should get the angle of prism. Angle of prism is what this particular thing is there. What to do with this 60 degrees? We know at minimum deviation, angle of incidence once again I'll take you to the basic idea. At minimum deviation, we do have a condition of like this: I, E, this is a R1. So the deviation will be minimum. So what is the minimum deviation formula? We'll write it I minus E into E, and I should be equal to E, R1 equal to R2. Angle of incidence should be equal to emergent angle. This is what that I is 60 degrees. So minimum deviation 60, so 60 equal to 2I minus A. What is the value of I? I is 60, so 60 equal to 2 into 60 degrees minus A. So A equal to 60 degrees. Now once you know A, substitute that A here. Mu is equal to root 3 by 2 by 1 by 2. Root 3 is asking to calculate the I1. How to calculate the I1? I think after getting the value of A 60, substitute here. I'll rewrite here. 63 plus A equal to 3I1. 63 plus 60 is equal to 3I1. So what is I1 is equal to 123 by 3. Manageable, all some formulas, and you should have that minimum deviation condition there. At minimum deviation, incident angle, emergent angle will be equal, and the refracting angles will be equal, and they should be equal to A by 2. At many problems, this is going to help you a lot. We'll take the next one. Two identical equilateral glass prisms ABC and CDE are kept such that the angle between the faces AC and CE is theta. A ray of light is incident at an angle I at the face AB and traverses through two prisms along the path PQ. Find the value of angle I and theta such that angle between the incident ray PQ and emergent ray TU is minimum. Equilateral glass prism system. So how we can bring for two prisms this? Only for one prism, okay, no, but the concept is brought for minimum deviation for two prisms. So from where to analyze the idea now? We'll calculate the angle of incidence. How to calculate angle of incidence means we'll take this R1, R2. First we'll calculate this angle and we know this is 60 degrees. At minimum deviation, because the ray is parallel to the base of prism, QR is parallel to BC. ST is parallel to CD. So therefore, we know R1 plus R2 is equal to 60, and at minimum deviation, R1 equal to R2. So therefore, R1 equal to R2 equal to 30 degrees will get it. Then sin I is equal to mu. It is mu sin R1. Mu is how much? Root 2. Sin R1, sin of 30 degrees. So sin I equal to 1 by root 2. So this angle is what? 45 degrees. Then this angle should also be 45 degrees. Equilateral prism. It's telling find the TU is minimum is telling. So therefore this angle should also be 45. This triangle 45 means this should be 90 degrees. Because he has put a condition, the deviation should be minimum, no? The angle between PQ and TU should be minimum. So therefore the theta has to be 90 degrees. Okay, so I how much? 9 theta 90 degrees. We'll take the one more. A thin glass prism has different mediums on its either side. A light ray is incident almost normally on the first rays. What is the angle of deviation if all the angles are very small? It's asking angle of deviation. I think little bit now. The medium on either side of prism is different. That the only thing is different. So we'll take the ray, undergoes refraction here. This angle, let it be R1, let it be R2, let it be R3. So small angle prism, so mu I is equal to mu to R1. Mu R2 should be equal to mu to R2. Applying Snell's law, sin I is equal to mu1 sin I should be equal to mu sin R1. So mu1 I, it is mu1 I. Mu1 I should be equal to mu R1. Mu1 sin I should be equal to mu sin R1. As small angles, so sin I will be I, sin R1 will be R1. So mu sin R2 should be equal to mu 2 sin R3. Okay, let me add up these two. Mu1 I, mu 2 R3 should be equal to mu R1 plus mu R2. So mu1 I plus mu 2 R3 should be equal to mu R1 plus R2. We know R1 plus R2 should be equal to A. From here, this part here. R1 plus R2 should be equal to A. So mu1 R equal to mu A. So what is R3 is equal to mu A minus mu1 R by mu 2. What is asking deviation. No? So what is the basic formula for deviation? I plus R3 minus A. R3 is what? Mu A minus mu1 R. This if I rewrite plus mu. This will be the expression for deviation. If the medium on either side of prism is different, the expression for deviation will be this one here. Okay. Okay, kids, we had some discussion of some good number of numericals. Hmm? I have to go to the college. Huh? So let me discuss few more problems in the tomorrow's class. Hmm? So almost I think some lengthy numericals I just picked up here to explain the concept of prisms. So tomorrow we'll focus on few more problems on the prisms. That will be the last topic on the prisms. Okay, fine. Okay, all of you, thank you very much. Please do share my app and the web information to your friends. So definitely it's going to help the most of the kids where I brought plenty of numericals here. So it will be like an inspiration for me also to further strengthen this app and web. Okay, thank all of you. Take care. Bye. See you. We'll meet in the next class.